Hello guys, welcome to my channel and welcome to the series of deploying on AWS Cloud by using Terraform. If you are new to my channel, don't forget to like, share and subscribe my channel right away.
Hello guys, welcome back to the screen and welcome back to the series of deploying on AWS Cloud by using Terraform. In today's part 8 of this series, we are going to deploy AWS Launch Configuration along with Auto Scaling Group. This would be an interesting topic because this is a kind of practice which is being used in industries whenever you launch your instances. And as part of the AWS well architectured framework, that is resiliency, Auto Scaling Group plays a big role over here. So let's jump right away to our agenda to understand what we are going to cover for today's video. Okay, so here we are. So the agenda for today is, first we will have a quick overview of AWS Auto Scaling Group, and then we will have an understanding of AWS Launch Configuration and how both of them correlate. Then we will understand the prerequisites. In this prerequisites, I would be talking about what all setup you would require, which should be available at your end before implementing this specific tutorial that we are going to do today. Then moving ahead, once the prerequisites done, we will talk about the architectural implementation, about what we are going to do today. Then we would go ahead and start configuring and deploying 4 resources. That would be, we would be creating security group for our auto scaling group. Then we will create a target group for our auto scaling group. Then a auto scaling group itself. Then the launch configuration. And I will show you that how you can associate all of them together to bring more value to the table. So let's go ahead and get started with our overview. Okay, so the first thing that we are going to see today is AWS Auto Scaling Group. What is exactly Auto Scaling Group? So Auto Scaling Groups automatically adjust the number of EC2 instances based on the defined policies, ensuring optimal performance and cost efficiency. What I mean by this? So if you see on the right hand side, there is a diagram over here. So this is a 3-tier uh, application architecture or implementation. So in production, you would have an implementation where you will have one layer of web servers, one layer of application servers, and the third layer is database. So this kinds of layering is being implemented on the production level. So where auto scaling group is going to play a role. So whenever you are going to have a web server layer, in that you would be having 2 to 3 instances that are running your web servers like Apache Tomcat or IS server if you have a Windows server. So in that case, to ensure that your performance is good and it is very efficient and during the business continuity it does not goes down. In that case, we can have auto scaling group configured for your web server fleet, in which as soon as suppose if you are having 3 servers and to serve the traffic minimum you require 3 servers. So if any one of the server goes down, automatically that server will come up as part of the auto scaling group. So that is the beauty of auto scaling. So the way I spoke about web server fleet, the same way you can do for application server fleet also, where you would be having 2 application servers which are up and running, and by any chance, if any of the application server goes down, application server goes down, you can also configure auto scaling group for your application fleet, so that if one of the server goes down, another one comes in. Now, these groups enable the dynamic scaling of application in response to changing demand and distribution traffic seamlessly. You can also configure it based on the demand that is coming in. So for example, you can have the count of concurrent users. So for example, if I am hosting one website and in one website, I know that my one web server is going to take a load of 200 concurrent users, not more than that. So that is the capacity for which I have configured my web server. So when you know this, so what you can do is you can have your uh, application dynamic scaling uh, policy set over there, and you can monitor the concurrent users, and based on the count you can route it to different servers, so that your one server is not overwhelmed with a lot of traffic which is coming in, which might bring it down. So that is one of the analogy that can take place over here. Apart from that, auto scaling groups enhances application availability, as if any of your application server goes down and another one automatically comes up, so it keeps your business going without any downtime for your users. So that is why it says that auto scaling groups enhances application availability. Now let's go ahead and see our next concept, what exactly it is. It is AWS launch configuration. So launch configuration is nothing. So whenever you are deploying your auto scaling group, so this is kind of a configuration, quick configuration that you have already set up, and by using this quick configuration you can immediately deploy your auto scaling groups. So over here you can see, so launch configurations define the configuration settings for the EC2 instances within auto scaling group. For example, if as part of the auto scaling group I have to launch 3 servers, So what those servers are going to be, what is going to be their AMI ID, what is going to be their CPU, what is going to be the count of uh, yeah, what is going to be the configuration. So all these things which comes as part of the EC2 configurations, as part of their arguments, you can configure that in your launch configuration, and you can pass it to auto scaling group to launch your EC2 instances at one go. So here, as I said, you can specify your AMI, instance type, storage, security groups, and a lot of more things as templates for the instances launched by auto scaling groups. So now let's go ahead and understand the prerequisites. So our first and foremost prerequisite is you should have your a custom VPC which should be deployed along with the internet gateway, and that internet gateway should be associated to the custom VPC via the main route table which is already available. Now, what I mean by this, uh, there is one video that is part one where I have created this VPC along with the internet gateway and I have associated them. So I will put a link in the description above. If you have not watched it, watch it, which it will help you to configure that specific thing. Once you configure it, so as part of prerequisite, what you should check, let me tell you that. So once you have done that, go to the VPC console, check whether your custom VPC is created. And when I go inside, it will also show me that it has the internet gateway associated with it. Okay, see, this is the main route table in which it has association. Now, if you go on the left hand side, you will also see the internet gateway. This is the internet gateway, and this is our internet gateway that should be there as part of our prerequisite that you can see over here. Okay, and you can see that this internet gateway is been associated with our VPC ID. That is the reason it is showing the VPC ID as well as the the VPC ID over here as part of the internet gateway. Okay, so let's go back to our prerequisite. So we have covered our first prerequisite. Let's understand our second prerequisite. So as part of this implementation, you would require two public subnets, public subnet 1 and public subnet 2 inside the VPC, that is a custom VPC that we have launched, because we are going to create our EC2 instances as part of auto scaling group into different availability zone. So if you have not configured it, I would put a link in the description above where the part 2 helps you understand how you can create a public subnet, and you can create two public subnets in two different availability zones. So for example, right now we are going to implement this in US West 2. So you can keep one public subnet in US West 2A and the second one in 2B. That is how you can segregate it. Once you have that implemented, you can go ahead and cross check that again. So for doing that, what you can do is go to VPC console once again, click on subnets. Under the subnets, you will see your public subnet which has been created. So over here you can see my public subnet 1 and public subnet 2 is already been created. Now just make sure that your public subnets have a custom route table associated with it, and this custom route table should have an entry for the traffic to flow in. It should be a public network. So if I open any one of the subnet ID over here, you can see it has a public route table associated to it. If I go to route tables, so this is my custom route table which has been associated. And if I click on this custom route table, it will show the internet gateway association as well as the uh, local destination over here. Click on subnet association, you can see the two subnets, public subnet 1 and 2. So that is how you reconfirm that your prerequisite 2 is in place. Now, as we have gone through our prerequisites, let's go ahead and understand that what we are going to implement today. So our implementation would be in this format, in which, as I showed, the internet gateway and the VPC comes as part of our first prerequisite. Then the public subnet 1 and public subnet 2 comes as part of our 7 prerequisite, where these all will be created. Now, the other thing that you see over here, this is what we are going to create now as part of this tutorial. What we are going to do is we are going to create an one target group, and in that, with respect to the target group, we are going to create an auto scaling group. That auto scaling group is automatically going to launch the EC2 instances into different availability zone. So right now you can see the availability zone over here is US East 1A and US East 1B. But in our case, right now I am going to deploy this in US West 1A and US West 1B. Oh, sorry, US West 2A and US West 2B. So that is the only difference based on the architectural diagram. So let's go ahead and let's get started with our coding part. So now, so whenever we start with Terraform coding, I always start with this three basics file, that is providers file, variables file and version file. So let's jump to our Visual Studio Code. And in this Visual Studio Code, you can see the provider that I have configured. It is a simple credential files pointing to my credentials. The region is US West 2, as I said you. And now if I go to versions, I have kept the version should be greater than or equal to 0.12. So that is the two files that I have covered. Now let's go ahead and jump to the third file, that is variables file. So this variable file is having a default variable AWS region. Now as we have covered these three files, apart from this, we are going to also add one more file, that is outputs.tf, but that I would be adding after uh, creating the resources that we are looking for. So let's see what resources we are going to create now, step by step. Okay, so what we are going to do is first we will be going ahead and creating a security group for our auto scaling group. So let me jump back to the screen. Before creating the security group, don't you think we should go ahead and create a main.tf file? Okay, so here we have our main.tf file. So let's quickly get started with our first resource creation, that is security group for our auto scaling group, and what all we are going to configure in that. So our first and foremost file is, I hope it is very well visible to you guys. And okay, so if I, yeah, in this, we are going to create a security group for auto scaling. In this, you will see I have used a resource AWS security group. And as part of this, we are creating a security group which is going to allow all inbound traffic for the auto scaling groups that we have configured. Okay, so over here you can see the VPC ID that we are going to do, the VPC ID that we want to add over here as part of this argument. We don't have it in our current code. So for that, we would be going ahead and writing a data block, and what the data block is going to do is it is going to fetch the VPC IDs for us. So let's go to variables.tf and let's create our first data source. So this data source is AWS VPC get VPC, and we are using a filter with the tag name. So our VPC that we have already created as part of a prerequisite, let me take you to that. If I go in my VPC and if I open this, so you can see this is having a tag as custom VPC. So this custom VPC we are going to add as our filter. Okay. Now, so as we have added this with our as our filter, so this would be picked as part of this argument and added over here. Now our basic configuration is done. Now we are going to do the configuration of inbound traffic and outbound traffic. So for inbound we use ingress. So as part of ingress I have kept 443. I have kept port 2022, port 22. Then I have kept an ingress of port 80, ICMP and TCP. So I have kept many options over here so that I can push this option to the GitHub repo and you can pick anyone based on your requirement. For our use case, we are only going to require ingress 80. That's it. Now for egress, I have left it as traffic should flow to all. Okay. And here we have added a tag, which is Terraform auto scaling group security group. Now that is the first resource that is been created without. So we have covered AWS security groups for auto scaling group. Now we will go ahead and create a target group. So let's jump back to our screen and let's go ahead and create our target group. So as part of our target group, what all information we would require and what all new variables we have to create. So as per my understanding, we don't require to create any variable. And as part of the AWS load balancer target group resource, we are defining the name as auto scaling group target group, the port as 80, the protocol as HTTP, and the VPC ID is the same data source that we have defined over here. That is to fetch the VPC ID for our existing custom VPC. Okay, so now we have covered the second part, that is AWS target group for auto scaling. Now we will be going ahead and creating a launch configuration. So first we would require a launch configuration, then we will have to create an auto scaling group. So as per our overview, I hope you remember that launch configuration is nothing. It is just a configuration for the EC2 instances that we are going to create as part of the auto scaling group. Okay, so what I'm going to do over here is I am going to go ahead and add a new resource. This resource is AWS Launch Configuration. What exactly this resource is? Let's go ahead and check the official documentation. So it provides a resource to create a new launch configuration used for auto scaling group. So as per the example over here, you can see this is the launch configuration for auto scaling group, which has been defined. So this is the resource, and in this you can give the image ID, the instance type, and the life cycle, that how this instances has to be created. Now, jumping back to our screen, what all things we have configured. Let me show it to you over here. So as part of this resource, we are giving the name as launch config dev. So the resource name is going to be launch config dev for us. Now the name prefix. So the name we are going to give as web tier dev, and the image ID I'm going to give as this. So this image ID is nothing. This is the image ID of Linux, Amazon Linux 2. Let me show you that. If I go to EC2 instance, click on launch configuration and scroll down, you can see this is the AMI ID that I am using over there. So that is what I have added over here. Now, as part of this instance type, we have to give an instance type. So for giving the instance type, we have to define that specific instance type, right? So let's go ahead and create a variable for that instance type right away. So let's define it as variables for auto scaling group. So the instance type I am giving over here is T2 micro. Okay. So our server which is going to be created, it is going to be T2 micro. Now, apart from that, do we require any other parameter? Yes, you require a key name if you want to log into that specific server and perform some activity. At the current moment, I am not going to add a key pair. The reason for that is uh, uh, it's optional. It's not a mandatory thing that has to be added to create the resource. Now, moving to the next part, that is security group. So over here in the security group, you will see that we have added the security group over here. And what is the security group? It is the same security group that we have created over here. So security group for auto scaling group EC2 instances. So this will clarify that this security group is going to be attached to the auto scaling group EC2 instances, which are going to launch as part of it. Now, after that, I have given that associate public IP addresses. So as we are creating the EC2 instances in a public subnet, I want a public IP address to be available so that it can serve the traffic from the web. Okay, I don't want it to be the private service. I want it to be available over the web. That is the reason I have added associate public IP address as true. Now, after that, I have added a user data script, which is going to install a HTTP server that is kind of Apache web server that we usually use to serve the web traffic. So over here, we are installing HTTPD. This is going to install the HTTPD, and as part of this echo variable, it is going to add a line into that index.html file saying that deployed EC2 using autoscaling group. So these are all the parameters that we are going to add over here as part of AWS launch configuration. Now, let's go ahead and see the life cycle. This is a very important parameter, and we will see this as part of the official documentation. Life cycle, sorry, C, life CYCLE. So where all we have the life cycle. Okay. So this life cycle will help us know the it should be created before destroy or true or not configuration parameters. And what that does that mean? Create before destroy. It is a Boolean value that Terraform must change a resource argument that cannot be updated in place due to remote API uh, limitations. So the create before deploy is a meta argument that changes this behavior so that the new replacement of object is created first and the prior object is deployed after the replacement. So for example, when EC2 instance is already in place, so it is saying create before destroy. Now, if we are going to create another resource in that place, so it is going to create the new resource first, then it will go ahead and complete the deletion of the existing resource which has been deployed previously. So that is the meaning of lifecycle. And if you want to understand more in depth that what are the further options that we have available over here, so you can also you can go ahead and check this official documentation of HashiCorp, which says that there are different types: create before destroy, then it is prevent destroy, ignore changes, and how it works, replace triggered by. So these are different parameters, and if you want, you can also add a conditional check for the same along with the lifecycle. Now, moving forward to our code once again. So we have now configured the launch configuration. So now after configuring the launch configuration, what we have to do is we have to finally go ahead and create our auto scaling group. So for creating our auto scaling group, we would again require some variables that we will see while we are creating our auto scaling group. So let's go ahead and define our resource, that is create the auto scaling group. Now in this auto scaling group, this is the resource name, that is AWS Auto Scaling Group, and this is the name that we have defined. So let's go ahead and see on the official documentation what this resource is all about. It provides an auto scaling group resource. Okay, uh, and here are all the different examples that has been mentioned. So if I scroll down and come to arguments, that is argument reference, in this you will see that you have to define the minimum size and the maximum size. These both are the required parameters. Without these parameters you cannot create your auto scaling group. So going back to our configuration, so over here you can see as part of the launch configuration, we have given the launch configuration that we have created above, which is going to tell him that this is the kind of EC2 instance which we have to create. It is going to have this AMID, this EC2 instance type, and this is the security group, and it is going to install with this specific script. So this is what we have defined as part of our first argument. Now moving back to our second argument, that is minimum size and max size. So this minimum size and max size usually varies from requirement to requirement. That is the reason we define this as part of the variables. So which helps us to later on update that. Okay. So what I'm going to do is I am going to go ahead and define two variables for both of them in our variables.tf. That's it. So it is going to give us variable auto scaling group minimum size we have kept as 2 and maximum size we have kept as 3. Now moving back to our code. So we have defined both of them. Now over here, this is an extra line. I will just remove it. Yeah. As part of this code, we have to actually define the target group ARNs. So it is not only one specific target group that you can focus upon, you can create multiple target groups. But that is the reason you can see I have added in this box, which specifies that this is a list and you can add multiple entries over here. But at the current moment, we have already created our auto scaling group, which is available over here after the security group. So this is our auto scaling group. We are referencing to this auto scaling group by writing an interpolation statement, which says that this is the resource name, this is the resource type of Terraform, and this is the resource name, and this is the attribute that we are looking for. So attribute is going to be the ARN of this specific resource, which is going to be created. Okay. Now, the next one is a VPC zone identifier. What is VPC zone identifier? Let's go ahead and check it. Zone. Yes. So VPC zone identifier is a list of subnet IDs to launch the resources in. So at the current moment, in the prerequisite, I said you that we are going to create two subnets, and those two subnets we are going to create in different availability zone. That is availability zone 2A and 2B. So the same way, what you can do is you can actually define what all subnets you have to launch your EC2 instances in. So I would suggest that whenever you are creating launching a EC2 instance, so as part of the high availability framework, we launch EC2 instances in different availability zone. So by any chance, if any one availability zone goes down, the EC2 instance can be spun up in another availability zone. So in that case, what we have to do is we have to provide them the list of the subnet IDs. Now, to provide them the list of subnet IDs, we have to fetch the list of the subnet IDs which are already existing. So for doing that, we have to use a data source. What is the data source? That data source we have to define in variables to fetch the list of subnet IDs. And how we are going to fetch that? So AWS subnets is the data source by using which we can do that. And in this, I have defined two filters. The first filter says that search for the subnet which is going to have the VPC ID, that is uh, our custom VPC that we have defined now. And the second filter says that the public subnet, the subnet that you're looking for, that subnet should be of type public. It should not be a private subnet. So based on both of these collaborative filters, it is going to give us the list of the subnet IDs that we are looking for. Okay, so that completes our all the resource creation part, and at the end I have added the keys tag over here which says key as name and value as auto scaling group dev. Okay, now all these informations are in place. Now let's go ahead and see if it is working for us by any chance. So if I go to run, sorry, where is terminal? Okay, new terminal, and if I go my previous one, we are in ESG group. So first and foremost, we are going to initialize our folder, that is Terraform init. Okay, so that has been initialized. Now I will clear the screen and I will run Terraform. So usually I follow this pattern in which I first initialize the repo, then I always run the Terraform format command. It actually formats all the files. So later on, when you're running a Terraform plan or Terraform apply, it should not give you any error. So that is the pattern that I follow. So right now I will do Terraform format. And as you can see, it has formatted the main.tf file. That means proper indentation has been provided to this specific file. Now, moving forward to our another command, that is Terraform plan. So, so whenever I run Terraform plan, I keep my fingers crossed so that I don't get any error for the implementation that I'm doing. So let's see if our specific code goes through. Yes, it is going through. Now, in the start, I said you that guys, this time we are going to actually add outputs, which will tell us that, which will give us the IDs and the information about the resources that has been created. So what I'm going to do is I will just go ahead and I am going to add one more file, that is outputs.tf, and I'm going to add few outputs. So the first output is going to be the security group for the auto scaling group of EC2 instance launch that we are going to create. The second one is the launch configuration resource that we're going to create, and the third one is the auto scaling group dev that we are going to create. So these are the three. So right now, if I may clear my screen, let me first maximize it and close this. Now, if I am going to run, let's try to increase the font more. Yeah, okay. If I'm going to run Terraform plan once again, at the end you will see the outputs that I have mentioned over here. See, these are the outputs that will be displayed along with the proper ID of the resource once I'm going to run a Terraform apply command. Okay, so let me go ahead, clear my screen once again, and let me run Terraform apply. Oh, sorry, auto. So we are going to run this specific command, that is Terraform apply auto approve. So this will not, if we use auto approve, then it is not going to ask us to again reconfirm whether we have to apply this specific resource. So at the current moment, before running this plan, let me take you to our EC2 instance console. Okay, I will click on EC2 instances. Right now, I will click on instances. You will see there is no instances which are running at the moment. Okay, it is totally blank. There is no instances. Now, after running this, it should create two instances because we have defined the minimum size of our auto scaling group as two instances. So let me just click on Terraform auto approve, and it should start creating our resource. Okay, yes, it is creating. Fantastic. Mhm. So till now, it has created our target group, security group, and right now it is creating the launch configuration for us. Okay, so guys, as you can clearly see that it has created our resources as well as the auto scaling group, and all the IDs are available here as part of our outputs. Now let's go ahead and cross verify. Let's jump to our console. We will start step by step. So let's first go to security groups to see if our specific security group is created. Yes, it is. And as you can see, Terraform ASG security group has been created. Now, going back, so after auto scaling group, what is the second resource that we created? It was our target groups. So if I click on target group, you can see the target group is also been created. Now, I'm not opening this. The reason for that is because I want to show you whether this specific target group is going to create our resources. Before that, I will show you the launch configuration and the auto scaling group. So let's go ahead and click on the auto scaling group, and you can see our auto scaling group is already been created, and this is our launch configuration, which I am opening in the new tab. So right now, you can see that our launch configuration is this, which is available, where we have defined the instance type. You can see the AMI ID. Then you can see all the configuration, the security group ID that we have defined. The IP address should be public. So all these things we have defined is part of this. And if you click on view user data, it will show the script that we have added as part of this launch configuration. Now, if I go to auto scaling group and click on auto scaling group, it will show us the activity that we have mentioned that the desired capacity should be true. That means minimum 2 EC2 instances should be up and running, and uh, minimum capacity is also the same, and the maximum capacity is 3. So if the workload is more, we can expand to 3 EC2 instances. Okay, and the launch configuration been mentioned over here, and it will show the activities, whatever is happening. So if you see over here, the activity history, this is of the activity history shows that the 2 EC2 instance has been launched, EC2 instance 1 and EC2 instance 2. Now this EC2 instance, we will just go ahead and check in the instances. Before that, I will take you to instance management, and over here you can see that the 2 instances has been created in 2 different availability zone. That is US West 21, this is the first subnet, public subnet that we have created, and US West 2 is the second public subnet. So right now this auto scaling group is, so this auto scaling group has actually went ahead and created 2 different subnets, sorry, 2 different EC2 instances in 2 different subnets. So that is the beauty of auto scaling group. And apart from that, if you want to expand the horizon of this specific thing, you can actually add many more monitoring options over here by the monitoring. You can see the monitoring dashboard, and you can also define some custom policies or dynamic scaling policies for your EC2 instances as part of your auto scaling group. So that is what you can define, and this is the 2 servers that has been installed over here. Okay, so I think that's it for this session, guys, in which we have actually created an auto scaling group, and along with the auto scaling group, we have went ahead and created the launch configuration, and we saw that how the EC2 instances are launched and how it can be expanded further as part of the dynamic scaling policy also if we want to expand it. Now, last but not the least, so this specific tutorial that we went through, right now I have a specific blog written onto it, that is uh, how to deploy launch configuration auto scaling group using Terraform. So this is having all the prerequisites along with all the documentation and the code, along with the architectural diagram representation that I have. So if you're looking for the documentation that has been uh, shown over here, so you will see all those documentation along with the commands that we have used over here. Now, apart from this, if you're looking for code, I have a specific code repo, which is this, and this code repo is having all the information. So as part of this specific video, we have around 8 uh, yeah, this is the part 8. So as part and you will see this series is containing all the blogs as well as all the YouTube videos as well as all the codes of all the specific parts that we have covered. So whatever you want, you can go ahead and refer it over here. So for this, what I'm going to do is I'm going to go ahead and I am going to add the link of the GitHub repository as well as the blog in the description below. Go ahead and check it out. Try it. If you have any questions, please let me know in the comment section. I try my level best to answer all the questions for you. And if you like the video, don't forget to like, share, and subscribe my channel. So see you in the next video of our Terraform series. Thank you and have a great day.